distortional stress criterion or the one Mises stress criterion. So how are you going to start your design? So your working stress must be greater or equal to the one Mises stress. But what will be your working stress? Or your design stress? If you are using one Mises, what should be your stress? Or the strength, sorry. Okay, so initially we started with the principal stress criteria. So this is the principal stress criteria. In your ultimate strength must be greater or equal to your first principle. But because we're designing, so instead of using this ultimate value, meaning a design for failure, so we have to use a safety factor. So with that safety factor included, we have now your design stress. So for example, you have now your, say, design stress, or strength, sorry, design strength. Design strength or your working stress. So this will be equal to that ultimate divided by a safety factor. So that in our design, using a principal stress criteria, your S ultimate divided by that safety factor must be greater or equal to your first principle. Now, what if you're using the von Mises stress criterion or distortional stress criterion? So I'm just going to make it simple. Von Mises stress criterion. So what do we have? So this stress strength here will be your yield. So this should be greater or equal to your von Mises stress. But since you have a safety factor, so Sy all over N. Okay, so use the same safety factor. Solve for that thickness. Now, if this one is not given, if the safety factor is not given, just ignore it. Just have one. So, but normally in design, and you should have known that already, you have mechanical design course as well as the materials and design. So you should be familiar on when or when not to use that safety factor in. So you know, right? I mean, you should know the use of a safety factor in. Anybody who doesn't know? Okay, so what's the thickness? So just continue and let's determine the thickness. So let's see which one is a more conservative approach.